So there everyone, for today's discussion, we'll be focusing on proving trigonometric identities, which is fundamental in skill in trigonometry. It involves showing that two trigonometric expressions are equal by simplifying one side using known formulas and logical steps. Let's break it down and learn how to master this process. Let's firstly define what is proving trigonometric identity more deeply. So proving trigonometric identities, it involves demonstrating that a given trigonometric equation or identity is true for all values within its domain. This process typically involves manipulating one side of the equation, often the more complex side, using known trigonometric identities and algebraic techniques until it matches the other side. Now, let me show you the list of trigonometric identities that you can use in simplifying and proving trigonometric identities. Firstly, we have reciprocal identities, which shows the relationship between trigonometric functions and their reciprocals. Next, we have the quotient identities, which links the tangent and cotangent to sine and cosine. And finally, the Pythagorean identities, which are based on the Pythagorean theorem.
Proving trigonometric functions is essential because it ensures the validity and consistency of mathematical relationship between various trigonometric functions. It helps establish a solid foundation for solving complex problems in fields like physics, engineering, and computer science, where trigonometric functions model real-world phenomena. Proofs provide a deeper understanding of why certain identities hold true rather than just memorizing them. Additionally, proving trigonometric identities simplifies expressions, making calculations easier and efficient. It also aids in solving complex integrals, derivatives, and differential equations, which are fundamental in advanced mathematical and application. Start by using basic trigonometric identities, simplifying expressions, working with sine and cosine, converting to a single function, multiplying by a conjugate, using symmetry and angle relationship, substitution and algebraic manipulation, cross-multiplying for proving equations, using special angles, transformation of trigonometric expression, and verification.
Guidelines in proving trigonometric function. Let's use this identity as an example. 1 plus secant times sine times tangent is equals to secant squared. The first thing we need to do is to work on the more complicated side, which is 1 plus secant times sine times tangent. After choosing which side to work on, we will now proceed to rewrite the problem. And we will get 1 plus 1 over cosine times sine over 1 and sine over cosine. After that, we will simplify it and get sine squared over cosine squared. We will rewrite it again to get an answer of 1 plus tangent squared. That is from Pythagorean identities, which is equals to secant squared. There we prove that 1 plus secant times sine times tangent is equals to secant squared.
Proving trigonometric function. In complex analysis and trigonometry, the term trigonometric conjugate is employed. Sometimes it refers to the conjugate of complex formulas using trigonometric terms, but usually it relates to the conjugate connection between specific trigonometric functions which are frequently stated in terms of complementary angle. Example of trigonometric function. Sine squared plus cosine squared is equals to 1. Another one is 1 plus tan squared is equals to secant squared. And the last is 1 plus cotangent squared is equals to cosecant squared.
The house of Joseph, and this is the mathematics talk about the proving of trigonometric function. And I hope you like it. And thank you for watching. And goodbye.